All right, welcome back, boys and girls. This is Mr. Mace again, and we are going to spend today learning about Unit 5, Lesson 6. If you have your math expressions book with you, it should be page 239, which is where we are starting for today. Now, some of today's lesson might take place directly from the book. There will also be some additional slides that I go through today that will hopefully help us to understand the concept of what we are dealing with today. Couple of things should look very familiar in here. We are continuing to deal with algebraic concepts and ideas. So you're going to see some variables. You're going to see some things in here that hopefully you remember. A variable is something that can change or stand for multiple options depending on what makes the statement true. All right. And the other thing that should hopefully look familiar to you is the word equivalent. We see the word equivalent obviously in dealing with fractions. And basically it's just a fancy way of saying equal to. Okay. We are looking to create expressions in this place that means they are equivalent to one another. Okay. And again, just like with other aspects or formats of math as well, there are different ways to write the same thing. So we can take that all the way back to numbers and operations where we write out the number 14 in word form. We could write it out in expanded form. We could write it out in standard form. So we have different ways to represent the same value. All right, and that's what we're basically focusing on here is we are looking for ways to either combine and make something more simplistic or easier to work with, or expand it and stretch it out to maybe give us a better idea of what it is we're dealing with. So just keep your mind around that we are basically just writing the same information in different ways, but it has to be equal to the original value. All right, so I'm going to read through the top section here just to kind of drive that point home, because I do think there are aspects of this that are very important as we get to this. It says equivalent expressions always have the same value. Basically means what I just said. A plus 2 plus 3 and a plus 5 are equivalent expressions because a plus 2 plus 3 is equal to a plus 5 for all the values of a. So no matter what we put in, what that means is no matter what we put in for a, if I put in a 1 for a, the answer is going to be the same. 1 plus 2 plus 3 is 6, and so is 1 plus 5 equals 6. If I put a 2 in for a, 2 plus 2 plus 3 gets us to 7, and 2 plus 5 equals 7. So we know that those are equivalent expressions because no matter what I put in for a, the answer will remain the same. Now here is when it is not equivalent, but it might seem like it is. Okay? A plus 5 and 3 plus 4 are not equivalent expressions because a plus 5 equals 3 plus 4 only works if I happen to put in a 2 for the a. If I put a 1 in for the a, clearly 6 is not equal to 7. Okay, so we have to look for situations in which no matter what I put in for that variable, I will end up with an equal number. That is what we mean by equivalent. Another aspect that we really need to keep in mind as we go forward here, guys, is are different ways to represent multiplication. And again, I can't speak to all the classes, but I know with my group we've talked about this multiple times. If we have a situation in which we have a variable in the problem, and we're talking algebraic concepts, we can remove any multiplication symbol and just place the number next to the variable. And that would mean the same thing as multiplication. So what I mean by that is this statement right here, 3c, means the same thing as 3 times c. Now remember that dot equals a multiplication symbol. Okay, and especially when we're dealing with algebra, we tend to remove the x as the times symbol because we use x as the variable very, very often. So we want to remove that from kind of consideration during our algebraic lessons, right? So basically these things all mean the exact same idea. A, B means the same thing as A times B. Now, this is the one that maybe we haven't spent as much time on, at least in my class I know I haven't. Whenever we see a parentheses, okay, something inside a parentheses, obviously by order of operations, it means we do that part first. But if we have a number, or a variable for that matter, that is up right next to a parentheses, like the 4 is in this case. So we've got the p plus 6 inside parentheses, but the 4 is butting up to it. That means that we will multiply 4 times whatever the answer is inside the parentheses. In this case, it's 4 plus 6, or p plus 6, so we don't know what p stands for yet. But if we plugged a number in for p, like 1, that would then become 4 times 6. Okay? So whenever you see a 4 right up next to that parenthesis symbol, it means the same thing as 4 times whatever is inside that parenthesis symbol. Remember, that dot also stands for the multiplication symbol. So the next thing I want to go through here is the bottom of this page, where it shows us a chart in different ways, and this is what I mentioned about writing numbers with different formats, or writing numbers in different formats. This is the same basic thing. We can also write expressions in different formats. And the first column is talking about having a situation or a problem, for example, or an idea that we need to figure out. Okay, example A, 3 identical packages weigh 1/5 of a gram each. Now in some cases, like example B, we don't have the number, but we've got a variable. So that's where it really starts to play in, is when we start including variables in these situations. But you can see that we can represent that situation as this diagram. This is what we mean by a diagram. And whenever we see the word each, it means that we are taking those things and it's going to be repeated. Each of those boxes is going to have the same number in it. And we know that repeating those things means, in most cases, that it'll eventually be a multiplication problem. But we can represent it as an addition problem like we have right here. This is repeated addition, so we could also represent that same situation as a repeated addition problem. Okay? Another way to write that would be to write it with the multiplication symbol. Now notice there is no variable, so I don't have the 3 right next to the 1/5, because that would represent a mixed number, and that's not what we're looking for here. Okay, so we can represent this example, or this situation, as a diagram. We could represent it as a repeated multiplication problem, or a repeated addition problem, excuse me, or a multiplication problem. Or we can also represent, in this case, the answer as, or the situation as its answer. So there are 4 different ways that we could represent what example A is asking us: as a picture, or a diagram, as a repeated addition, a multiplication, or combining it all together to make it what we consider to be its simplest form. We've combined everything that we can combine. Okay? So example B is in the same idea, okay, same situation, only instead of including 1/5 in the situation, we've replaced that with the variable A right here. So you can still see it's 3 identical packages. And now instead of it being 1/5, we have A grams, meaning we don't know how much each package is, but we know that they are all the same. So this is an A, this is an A, and this is an A. And as long as that variable is the same, we know that that is repeating. That is an equal amount in each of those. So we can represent, just like the one above it, instead of representing it as a repeated addition of 1/5, this would be a repeated addition of 3 A's. Okay? So again, looking at the comparison between these two examples. And the only difference is we've gone from numbers, a numerical expression, to an algebraic expression. All right? And so again, looking here, instead of saying 3 times 1/5, we can do 3 times A and represent it that way. Or we can combine it as much as we can. Now again, you might say, well, Mr. Mason, the first one we actually got to the answer. Well, there's no answer. It's just combining it and simplifying it to a single unit, or to a single idea. We've simplified example B as much as we can. We don't know what A represents at this point. They haven't told us. So we know that A, whatever it ends up being, times 3, the 3 boxes that we have, will give us our eventual answer, our eventual number. Okay, so hopefully that makes sense to you. You can see the relationship between a numerical expression and an algebraic one, where we can combine it down to what I would call its simplest form. So now the next one, we're actually trying to solve it out. We're trying to stretch it out and make sure that it we can represent these in different formulas. They're not giving us those ideas right now. All right, so we got 2 boxes that hold B books each. They've given us the diagram. Okay, again, just giving us what we see up here. We know we've got a B there. Now, the addition, the repeated addition piece is we've got 2 boxes that are B each. So that's simply going to be B plus B. Not a lot of repeating, but B plus B. 2 boxes at B books each. That would also stand for, I can do 2 times B, written with the multiplication symbol inside of it, or I can combine it and take that out of the equation and make it 2B like that. So those are different representations. Those are different ways to write the same situation, right? The same expression. All right, I'm just going to do 2, and then we're going to move on to the next page here because I think that gives us a pretty good idea of what we're looking at here. So the next one says 4 bags with C peaches each. So again, I'm going to have 4 boxes. I'll just draw one big box first and then break it up into 4. Okay, and it says that each of these will have C peaches. And again, the variable can change to whatever they determine the variable to be. Some cases you get to select the variable. Okay, so just be aware of that as well. Sometimes it is in our opportunity to select the variable ourselves. Now, the next column, we are putting together the repeated addition version of that situation, which would simply be C plus C plus C plus C. They show us, again, the example of 4 times C with the multiplication symbol inside of it, or we can represent it without the multiplication symbol, and we can combine those 2 terms to get to 4C, because that means the same thing. Those are equal to one another. All right? Now, another thing we can do to help us visualize and understand these concepts is that we can use sticks. I used to call them sticks and stones when I was teaching younger elementary kids, but we've got sticks and squares. Now in this case, a little bit different than sticks and stones, what was place value when I was teaching younger kids, this is going to represent variables and whole numbers, okay? And they have different meanings, okay? The variable is the repeated aspect of something we don't know, but the whole number in most cases is going to be the number that we add to whatever the repeated variable is, or the repeated aspect of it is. So we can look at the example here that they give us. We can see that we have 3 sticks, which would represent 3 x's right over here. And we can see that we've got 2 individual boxes here, and those will not be added to the 3 or to the x's because they're separate. It's a different unit. So an example of a situation for this one would be if I've got 3 boxes of apples with X apples in each box, but then I've got 2 apples left over. Okay, so I can't put those apples in the boxes because that would make them uneven. I don't put them in until after. Again, order of operations. I would multiply to figure out how many apples I have in the boxes total, and then I would tack on the 2 extra apples at the end. Okay, so hopefully that makes sense. These are the repeated each groups, the multiplication piece, and then the additional extras, the leftovers, the things that we couldn't fit in those boxes are behind it. All right? So here's what I would like you to do at this point is I would like you to try and solve these 6 problems on your own. And again, when we come back to the next video, I'm going to make a second video here for you. I'd like you to, before you start that second video, attempt to try to answer these 6 problems. One is taking the sticks and stones model, or the sticks and boxes, and making it into an expression. And the second one is to take that expression and draw the picture for it. So pretty straightforward stuff, I believe. But I would like you to attempt that on your own, and we will come back and I will give you those answers and we will continue with our lesson.